Thus far, you've created the walls and roofs for this model. The next step in this project is to create slabs for the first and second floors. As usual, you'll need to set up 2 new design layers to begin, one for each slab. Since you've done this a few times now, we'll move through this process a little more quickly. Go to the Design Layers tab in the Organization dialog box and select Design Layer Foundation. Then, click the New button. In the New Design Layer dialog box, name the design layer Slab 1. Check Edit Properties After Creation and click OK. In the Edit Design Layers dialog box, set the elevation and layer wall height fields to 0. Then click OK to create the design layer. You need to create one more design layer for the second floor slab. To do this, select Slab 1 and click the Duplicate button. This will create a new design layer, which you should name Slab 2, and will be stacked directly below Slab 1. This slab should actually be stacked between Floor 1 and Floor 2. To change the stacking order of the design layers, click and hold in the digit located to the right of the design layer name in the number column. Then, drag your cursor upward until a bold horizontal line appears between Floor 1 and Floor 2. Now release your mouse button. As you can see, Slab 2 is now stacked between Floor 1 and Floor 2. Aside from the stacking order, you also need to change the elevation height for Slab 2. So select the Slab 2 layer and click the Edit button. When the Edit Design Layers dialog appears, input 10 feet 8 inches in the elevation field and click OK. Next, set Slab 1 to be the active design layer. Now, make design layers Scan 1, Slab 1, and Floor 1 visible. All other layers should be set to invisible. Click OK to close the Organization dialog box. Finally, go to View, Layer Options, and choose Show Snap Others. Now we're ready to begin drawing the slabs. Just as you did with the roof objects, you'll first create the shape with basic 2D geometry and then convert it to a slab. To begin, go to the Attributes palette and select any shade of tan for the fill color. To do this, simply click on the color swatch below the paint bucket icon. At the bottom of the color picker, select the Vectorworks Classic color palette, then select a color. Additionally, in the Attributes palette, click the Opacity button, which is just below the pen color swatch, and set the opacity slider to 50%. Now select the Rectangle tool from the Basic Tool palette. Also choose the first mode, Rectangle mode, in the toolbar. After that, click at the top left corner of the building, where the horizontal and vertical walls meet. Then at the bottom right corner on the opposite end of the building, click once more to create the rectangle. Notice you can still see the walls beneath the rectangle, since we set the opacity for this rectangle to 50%. You'll also notice that the rectangle extends past the building walls near the building entrance. Let's take a second to fix this. Again, select the Rectangle tool in the Basic Tool palette, but this time choose the last mode. Now, you'll need to use the scan of Floor 1 to snap to the point where the window wall at the entrance and the horizontal wall below that window wall meet. After locating this point, click to set the first point of the rectangle. The second mouse click will set the rectangle's angle. So move your cursor upward and slightly to the right until you reach the angled wall above. When you see the cursor cue Object/Perpendicular, click once to set the angle. With the last click, you'll set the rectangle's width. So move your cursor to the left until you have passed the leftmost vertical wall of the building, then click to create the rectangle. You can use this newly created rectangle to clip a section from the larger rectangle you previously drew. Hold the Shift key, and with the Selection tool, select both rectangles. Next, go to Modify, Clip Surface. Initially, it might seem as if nothing happened, but if you press the Delete key to remove the small rectangle, you'll see that the clip was successfully completed. Additionally, if you select the larger rectangle, you'll notice in the Object Info palette that the object has been changed to a polygon. You'll also need to clip the area inside of the round walls from the existing polygon. To do this, select the Circle tool from the Basic Tool palette, and make sure the first mode, Circle by Radius mode, is enabled in the toolbar. Then, to start the circle, click at the center of the round walls when the cursor cue Arc Center appears. To complete the circle, click anywhere on the inside face of the round wall. Next, with the Selection tool, select both the circle and the remaining polygon. This time, right-click the circle and select Clip Surface from the context menu. Again, since the selection state is changed, only the circle is selected. Press the Delete key to remove the circle. As you can see, the proper clip has been created. We're almost done creating the slab. Now we need to clip a few more extraneous areas before we can complete the polygon that will be used for the slab. This time, we'll use the Clip tool as a different approach to clipping objects. To begin, select the polygon. Then select the Clip tool from the Basic Tool palette. Also in the toolbar, enable the first mode, Exclusion mode, and the fifth mode, Polygon mode. There are only 3 vertex points along the inside face of the walls that need to be exact for the clipping boundary you are creating. Please click on these points in the same order as shown. Then, for the remainder of this polygon, simply set the points as close to the same area in your own drawing as possible. The last click to create the clipping boundary will be the same as the starting point. Once the last point is set, the polygon will be clipped according to the shape you just drew. Let's use the Clip tool once more to clip this bottom portion of the polygon. Again, just follow the order used here to set your own points for the clipping boundary. Remember that only the points along the walls need to be exact. The rest of the points need only be relatively close to the area shown here. Just as last time, your start and end points should be the same point. Once we've completed it again, the polygon will be clipped accordingly. Notice in the Object Info palette, because of the way the polygon was clipped, there are 2 polygons instead of 1 now. Now you're ready to convert these polygons into a floor. To start, switch to the Selection tool. Select the larger of the 2 polygons and go to AEC, Floor. In the Create Floor dialog box, set the bottom Z field to -12 inches and the thickness field to 12 inches. Then click OK to create the floor. Notice in the Object Info palette that the object is now a floor. Next, you'll select the smaller polygon and again go to AEC, Floor. Use the same parameters as before and simply click OK to create the object. Creating the lecture hall slab. The last portion of the slab that you need to create for this floor is the auditorium or lecture hall. Here's what that floor in this section looks like. Each level is 1 foot 6 inches higher than the level before it. This is so the people on each level can see the presenter or lecturer in the center of the floor. Therefore, instead of using the floor command as we did before, we'll create a sweep, since this portion of the floor is cylindrical. To create a sweep, you must first make a profile shape that will sweep around our defined access point. Additionally, to make things easier, we'll use Floor 1 Scan as a reference to create guidelines before we perform the sweep. First, select the 2D Locus tool from the Basic Tool palette. Now, click at the center of the existing round wall, then the cursor cue Arc Center appears. After setting the locus point, zoom into view so that you can see the detail in the Floor 1 Scan in the auditorium. Pan if necessary so that the locus point is on the left side of your drawing area. Next, go back to the Basic Tool palette and select the Line tool. Then click to set the first point of the line when the cursor cue Arc Center appears. Hold the Shift key and move your cursor to the right. Once the cursor cue Horizontal appears and your line is extended past the round wall, click again to create the line. With the line still selected, go to Modify, Guides, Make Guide. Notice the line style has changed to a purple dashed line, which is the line style used by default for guides. Furthermore, the selection highlighting has changed to gray. The gray highlighting means your selected object is locked, which you can also see in the Object Info palette. Also in the Object Info palette, notice the Lines class has changed from the None class to the Guides class, which is automatically created for the first time makeGuide command is used. Now we need to create duplicates of this guide, with a spacing of 1 foot 6 inches between each guide. For this, select the Move by Points tool in the Basic Tool palette. Also enable Move Mode and Object Retention Mode in the toolbar, and set the Number of Duplicates field to 3. The line you drew earlier should still be selected, but if it's not, hold the Command key on a Macintosh or the Control key on Windows to temporarily enable the selection tool. Select the line and then release the Command or Control key. After that, click on the existing locus point when the locus or endpoint cursor cue appears, and press the Tab key to enter the length field on the floating data bar. Input 1 foot 6 inches and press the Enter key to lock in the value. Then hold the Shift key and move your cursor upward. When the cursor cue vertical length appears, click to create the duplicate guides with this spacing. Next, switch back to the Line tool in the Basic Tool palette. Draw a vertical line from the point where the first row of seating in the scan layer and the bottommost horizontal guideline meet. Remember that the scan layer does not have any snapping points, so use the snap loop to set the most accurate point as possible. Do the same thing for the remaining 3 rows of the scan layer. Lastly, select all 4 of the vertical lines, and again go to Modify, Guides, Make Guide. Creating the guides in this way will make it easier to create the sweep profile to ensure it will match the floor scan. With the guides completed, it's time to move on to creating the actual lecture hall floor with the use of the sweep command. To begin, you'll need to create the sweep profile. To do this, select the Double Polygon tool from the Basic Tool palette and click the Preferences button in the toolbar. From the Double Polygon Preferences dialog box, set the separation between the 2 lines to 4 inches. In addition, choose Create Polygons from the Options section and click OK to return to the drawing. To create the double polygon using the existing guidelines, click on the following snapping points in the same order as shown here. On the last point on the wall, double-click to finish the polygon. Notice that a closed polygon is created after you double-click. Now, set design layers Floor 1 and Scan 1 to invisible so you can get a better look at the polygon. Also change the Plane drop-down menu in the Object Info palette to Screen. You should notice each level of this polygon is representative of levels or steps of the lecture hall floor. The last thing we need to do is angle these steps to represent the angle of repose you would see in a real-world situation. With the polygon selected, switch to the Reshape tool in the Basic Tool palette, and make sure Move Polygon Handles mode is enabled in the toolbar. Next, click this vertex point. Then press the Tab key to enter the length field in the floating data bar. Enter a value of 8 inches and press Enter to lock in the value. Now hold the Shift key and move slightly to the right. Once the cursor cue horizontal length appears, click. Repeat this process with these remaining vertex points. Here's what you should have once completed. The sweep profile is complete, so you no longer need these guides. To delete them quickly, switch to the Select Similar tool in the Basic Tool palette. Then select any of the guides and the rest will be selected as well. If you were to press the Delete key right now, none of the selected guides would be deleted because they're locked. To unlock the lines, go to Modify, Unlock. After unlocking, you can press the Delete key to remove these guides. You can delete the locus point too. Next, let's switch to a right view. Then select the polygon and go to Modify, Move, Move. In the Move Selection dialog box, choose Cartesian and set the X offset to -4 inches and the Y offset field to 0. Press OK to move the polygon accordingly. Now go to Model, Sweep. Since you want the selected polygon to make a complete 360 with no additional pitch, you can leave all of the parameters at their defaults and click OK to create the sweep. In the navigation palette, set the Scan 1 and Floor 1 design layers back to visible. Also, return to a top plan view. When you switch back to top plan, you may see the sweep is not in the correct location. To fix this, just select the sweep and drag it by its center point in the middle of the existing round wall. When the cursor cue Arc Center appears, release your mouse button and move the sweep to that location. That's it for the first floor slabs. You can set design layers Floor 1 and Scan 1 to invisible, render in OpenGL, and use the flyover tool to see what you've got so far. Once you're done, return to a top plan view. The first floor slab is done, so we'll be continuing on with creating the second floor slab. In the navigation palette, set design layers Slab 2, Floor 2, and Scan 2 to be the only visible layers. Also, make Slab 2 the active layer. Just as with the first floor, much of the slab creation will rely on the following existing walls, but this time the walls we use as a reference will be from Floor 2. There's only a small section that doesn't have existing geometry to reference, and that's this area, which is actually a balcony with the handrail. So let's start by drawing the handrail shape first. To create this curved handrail shape, you'll need to use the Polyline tool in Point on Arc mode. Select this tool from the basic tool palette, and also select the correct mode in the toolbar. Take a look at this curve. You can see it's basically composed of 3 arcs. With the Polyline tool in this mode, you can draw all 3 composed arcs with one shot instead of having to trace each arc separately and then snapping to the endpoints and compose them. To begin, click on the topmost endpoint of this curved shape. Next, click anywhere along the current arc. Then, click somewhere near the endpoint of the current arc, which will also be the start point of the next arc in the shape. Use the scan as a reference for the best place to set this point, based on the curve of the arc. Now you can move on to the second arc in the shape. Again, you've already set the start point, so the next click can be anywhere along the arc. Then the last click defines this arc's endpoint, and the next arc's start point. Once more, click anywhere along the last arc, and double-click at the arc's endpoint to create the polyline. There, you've created the handrail profile in just a few short clicks. You can now switch to the Polygon tool in the basic tool palette to finish creating the rest of the floor profile. Also, enable the first mode, Polygon from Vertices mode. Click at the topmost endpoint of the polyline you just created, and hold the Shift key while moving your cursor upward. Then, double-click on the inside face of the first wall you reach. With the Polygon tool still active, click on the bottommost endpoint of the curved polygon, and then follow the straight line that is connected to the curve in the scan layer. After the cursor cue, 30 degrees appears. Click somewhere near the end point of the line to match the scanned layer. Now, double-click the inside endpoint of the wall located to the top left of your current point. Next, press the X key to switch to the Selection tool. Select the curved polyline and the 2 polygons we just created, and go to Modify, Compose. The object should be composed into one polyline, as reflected in the Object Info palette. At this point, you can switch back to the Polygon tool, the basic tool palette. Enable Vertex mode if it's not already active in the toolbar. The remainder of the vertices should be relatively quick to create, as they are snappable points from the inside face of the walls from the second floor. For that reason, you can set the design layer Scan 2 to invisible in the navigation palette. Furthermore, please set your vertex points to the same location and in the same order as shown here. don't forget to double-click your endpoint to complete the polygon. Switch back to the Selection tool. Hold the B key to enable X-ray Select. Select your newly drawn polygon and the curved polyline, and then again go to Modify, Compose, to convert these two objects into one large polyline. As you can see, this is only a portion of the remaining slab. So again, enable the Polygon tool in the Basic tool palette, and follow the vertex points set in this video, and set these same points in your file. Just like last time, don't forget to double-click to complete the polygon. The last portion of the slab you need to create is in the bottom right corner. It's also the easiest to create. Temporarily make Floor 2 the active layer in the Navigation palette. Then simply enable Inner Boundary Mode in the toolbar and click inside these three walls, and the polygon will immediately be created. With the polygon selected, change the Layer drop-down menu in the Object Info palette to Slab 2, and make Slab 2 the active design layer once again. Now all of the profile shapes needed to create the floor are complete. The last step is to convert these objects into a floor. Press the X key to activate the Selection tool and select the polyline and the two polygons. Then go to AEC Floor in the Create Floor dialog box. Set the bottom Z field to -1 foot and the thickness field to 1 foot. Lastly, click OK to create the floor. Notice in the Object Info palette that only one floor object was created, even though multiple 2D objects were used in its creation. At this point, you've created all the slabs, walls, and roofs for this building. Take a second to set all the design layers to visible, except for the scan layers. Switch to a right isometric view, and render in OpenGL to see your progress. Feel free to use the flyover tool as well to see more angles of your building. As always, once you've finished, return to a top plan view.